Assalamu alaikum. Hello everyone. I am MD Kolam Zakaria. Today I will present my work on experimental investigation of impulse characteristics of conventional ground electrodes in dry soil. So I want to start from introduction. So grounding systems are essential for safely dissipating lightning and high voltage currents. So however, in dry soil conditions, the performance of grounding systems becomes poor due to high resistivity. Previous studies suggest that soil ionization plays a key role under impulse conditions, especially in dry soil, so where air void dominate conduction. So the objective of this work is to experimentally investigate the nonlinear behavior and ionization characteristics of dry fine sand under impulse voltage. So here is my methodology. So at first the dryness of the sand was confirmed using a soil moisture tester. Then the dry sand was placed inside a hemispherical electrode configuration to ensure uniform electric field distribution. Then high voltage impulses were applied using an impulse generator in stepwise increasing levels. So then we control the time intervals 5 minutes because you know to we need to eliminate thermal effects and ensure that the observed behavior is due to ionization, because when we apply high voltage, like if you apply 5 kV, 10 kV, 15 kV, then the soil becomes heat, more heat, it can gain heat. So we need to remove the heat, because if we inject 5 kV, the soil will be heat, right? So again, if you want to if you want to inject 10 kV instantly, since the soil is already got an heat, so the we can get current immediately just because of this previous heat. So we need to remove the heat because of the previous injection. That's why we need to give rest to the soil. So we maintain 5 minutes. Okay, then voltage and current signals were recorded using an oscilloscope and saved as CSV files, which are later analyzed in Excel to obtain waveform characteristics. Okay, so here is my results part. So the initial behavior of my results, here you can see. This is this orange color is indicating the current waveform, and this blue color indicating the voltage waveform. That means till 40 kV we didn't get any current. You can see here the current level is almost linear to zero, and we can see the voltage graph is high. That means which one we are injecting, we can get the same voltage but no current, because the soil is showing its behavior like a resistive behavior. So that means initially it's a highly resistive material. This is the first thing. Second thing, when the voltage reached around 50 or 55 kV, current is inception occurred. This indicates the onset of soil ionization, mainly occurring in air voids between particles. Okay, also you can see here the effect of polarity is actually the effect of polarity shows here very weak polarity dependence. Okay, so at 55 kV, significant ionization currents were observed. Is reached up to 136 ampere almost for positive and negative 104 ampere. That means this confirms that ionization dominates the conduction mechanism at high electric field strength. Okay, so this result, that means these results clearly indicate the discharge process is primarily governed by electric field rather than polarity, and also due to controlled time intervals, thermal effects are minimized. So confirming that the observed conduction is dominated by ionization mechanism. So in conclusion, a dry soil initially behaves as an insulator but undergoes a sharp transition to ionization behind a critical threshold. The polarity effect is minimal and the overall behavior is dominated by electric field intensity. These findings are important for improving grounding system design under lightning condition. So this study not only confirms existing ionization models but also proves experimentally validation under controlled laboratory conditions. So thank you everyone. Assalamu alaikum.